You have an angle alpha in standard position with its terminal arm in quadrant 3, and cos alpha is negative 3/5. An angle beta in quadrant 2, and sine beta is 1/3. Determine the exact value of sine alpha plus beta. Okay? Now, of all the questions, if I would show you questions that you would do in grade 12 pre-calculus in grade 11, this one I think is one of the scariest looking. But it's an actual really easy question if you recognize what kind of question it is. I give this one a name. I call this a double triangle question, because you're going to make a triangle for alpha, which is in quadrant 3, and you're going to make a triangle for beta, which is in quadrant 2. So I draw my quadrants, and alpha is in quadrant 3, so I draw an angle in quadrant 3, go back to my nearest x-axis to make a triangle. Right? We always go back to our nearest x-axis because then this is going to be my alpha reference angle. This is my angle alpha, but that's my alpha reference angle. And if I draw that triangle, it tells me that cos is negative 3/5. So adjacent over hypotenuse will be 3/5. A squared plus b squared equals c squared. That will be 4. So we already knew that cos of alpha was negative 3/5. We now know that sine of alpha is negative 4/5. And I know sine is negative as well because it's in quadrant 3. And according to my CAS rule, sine is negative in quadrant 3. Then I draw a triangle for my beta. It tells us that beta is in quadrant 2. Nearest x-axis. This would be my beta reference angle. This is my actual angle beta. But there's my beta reference angle. They tell me that sine of beta is 1/3, so I can label this as 1 and 3. A squared plus b squared equals c squared. We'll get that side length to be the square root of 8. So I already knew that sine of beta was 1/3. I now know that cos of beta is negative root 8 over 3. Again, negative because cos is negative in quadrant 2. So it's a double triangle question because you're going to draw a triangle for alpha and a triangle for beta. And then the question asks us to find sine alpha plus beta. And we go to our formula sheet, and it's equal to sine alpha cos beta plus cos alpha sine beta. And from here, we just have to plug in values. So I want you to write the next step, because there is a very common mistake. I take statistics every year. There's a very common mistake that happens next. If I do it right, and you watch me do it right, if you are prone, it's like almost genetic. If you're prone to making the common mistake, you will make it whether you see the right way to do it or not. So right now, I want you to go with your gut, what you think you should do in the next step. It's just plugging in values, okay? All the values are there on the right. You just have to plug them in. I mean, all the values are on the left. You just have to plug them in on the right to do the next step. But there's a common mistake that happens, and it's usually about 50% of students make the common mistake, so it's like, that's pretty common. So I take statistics. You write the next step. You're unsure of yourself, you can do it in pencil. Okay? The common mistake is that students put in the number just for alpha. But you do not know what alpha is. You know sine of alpha equals negative 4/5. You don't know what alpha is. Which means you replace all of the sine of alpha. The sine would go away. You would replace all of that with negative 4/5. But you're so used to just replacing a variable that you want to just replace the alpha, okay? Does it make sense that you have all sine of alpha? This whole thing is -4/5, so this whole thing gets replaced with -4/5. Cos of beta, this whole thing is -8/3, √8/3. Cos of alpha, that whole thing is -3/5. And sine of beta, that whole thing is 1/3. Now we just have to multiply tops, multiply bottoms. This will be 4√8/15 plus, actually, positive times negative will be subtract 3/15. I have a common denominator. So for simplifying your answer, you are not done until you have a single fraction written. So I have to write it as 4√8 minus 3 all over 15. So taking away that question, one of the things that people like about chapter 7 is there are some predictable questions, like double triangle questions are very predictable. They're often worth 3 or 4 marks. And if you know how to do them, they are very easy. So questions for practice on this one are 8 and 13.